All right, let's get started, everyone. My name is Jim Manico, and I'm here to talk about the OWASP Top 10. OWASP is the Open Web Application Security Project, and it's a nonprofit charity around the world that promotes knowledge and tools for free around the topic of web security and application security. But what is this OWASP Top 10? The OWASP Top 10 is a top 10 awareness list that the OWASP Foundation releases on a 3 or 4 year schedule. And this is an internationally famous list that lists the 10 most critical application security risks that we see in the world of web security today. Now, the project members who work on the OWASP Top 10, just like Oh My Hack, they're members from all over the world who volunteer their time and expertise to produce this list. The members of the team are Brian Glass, Andrew Vanderstock, Torsten Gigler, and Neil Smithline, 4 researchers I know personally, and I'm very proud of their work. Of the OWASP Top 10 items, 8 of these items are chosen from data and data study of hacking and vulnerability data that we see around the world that's been submitted to the project during a call for data. 2 of these items are chosen from votes from the community of professionals that work with the OWASP Foundation. And so that's how this list is made. And by the way, the OWASP Top 10, it is not a standard. It's really an awareness list for conference talks like this to help us bring new awareness to certain categories. If you want a standard, after you read the OWASP Top 10, I would recommend that you read the OWASP Application Security Verification Standard. That's a more comprehensive standard with 300 different requirements. However, the OWASP Top 10 2021, it's a great thing to talk about for a conference like this and for an awareness training and a variety of other purposes that makes the OWASP Top 10 a very useful document. So let's get started. The first category in the new OWASP Top 10 is broken access control. Now, think about access control. This is a very plain category that we've known about for maybe 50 years. I know some of the original research on access control design showed up in the 70s by Dr. Salter and Schroeder, and even earlier by other researchers. So why is this very old and very plain category number 1? Well, first of all, when we looked at the data study, 94% of applications had some kind of broken access control. So this is one of the most popular vulnerabilities that we see in applications today. The other challenges are access control is difficult to test from automated tools. Your scanning tools are rarely aware of the custom access control policies that are built into your software. And so I know that those of you who are pen testers, who are manual expert security testers, you can find access control, I'm certain. But the era right now of security in applications, it's all about DevOps. And one of the hearts of the DevOps movement is to do automated scanning as the focus of your security testing. And let's just be really clear. This big movement of doing DevOps, of using automated tools and automated build processes, it's almost useless in finding access control vulnerabilities. And this is really a big deal to me because I think access control being number 1 is a good idea because of these big problems. Also, as a developer, when you ask me to fix access control, it's often not easy. Our frameworks rarely provide detailed enterprise access control functionality. So at some level, it's hard to test access control with automation. There are a few tools out there that do it, but that's the exception, not the norm today. And it's also, as a developer, it is not easy to build access control There's no standard way to do it. And these are the reasons why access control in 2021 is the biggest problem identified by the OWASP Foundation. Now take a look at this problem here. How would I hack this URL to break their access control system? This is a vulnerability called indirect object reference, IDOR. I don't like that name. I call it horizontal access control or data specific access control. So my question is, if you were a hacker or a security tester, how would you violate the access control of this URL? Of course, it's very easy. I would just change this number, and underneath the hood of the database, it's just pulling down SQL and executing SQL against the message table. Now, this is a very common problem in software all over the world. I use like Burp Sequencer or some other tool, and I can try every number. And so how do I fix this problem? How do I fix indirect object reference? Well, it depends on your business logic rules. It depends on what the policy is of your business. In my application here, only someone who sent the message or received the message is allowed to view this message, right? So I solve it this way in the database. I say, and let me check this out. I'm gonna go to pointer options and I'm gonna get the blue pen out. All right. So take a look at this right here. We see that we look where the message ID is 1, that's this ID submitted by the user, and the owner of the message and the recipient of the message, or the recipient of the message, is the user who's logged in, either by session or by a JSON web token. And look, this will solve the problem, but this is just one way to solve the problem. What if the owner, the recipient, and the manager of both users could look at that message? Or what if the owner, recipient, and team members could look at that message? I don't know, but every application has a different policy, and the scanning tools that we use don't understand our policy. This is why access control is the biggest problem we see today. And so another piece of advice is, don't hard code roles, right? One of the ways of doing access control design is hard code roles. And I recommend instead code to the activity or the feature name. It provides for a much more flexible policy enforcement point within your software. Here's some other design concepts around access control. Again, we want to enforce access control by the activity or feature name, not the role. We want to implement a standard data-specific access control design so developers can leverage that in a standard way and not have to guess on their own. We want a centralized access control system and a filter where all access control requests must go through our access control layer in some way. We also want to deny by default and fail when things go wrong to provide access. Use the right server-side data to make access control policy decisions. And if I want to change the configuration of a user, I want those changes to take effect in real time, even if that user is currently logged in. And last, I want to have a good data model for my access control design with proper grouping for users and permissions, and much, much more when I design the database to represent my access control. I also recommend you take a look at the Application Security Verification Standard. If you look at the latest released in version 4.0.3, we define a series of additional access control requirements that you should be considering for your developers and for your projects. So access control is hard to add to an application late in the life cycle. So I do my best to build access control up front early with the most senior developers that I have on my team. I also want to realize that the tools that we use are poor at finding access control problems. So you may want to consider unit testing and other methods for automated testing besides the dumb scanners that the DevOps movement depends on. You know, as a quick note, DevOps is kind of weird to me because I've looked at the tools that we use in application security, static analysis, dynamic analysis, and software composition analysis tools. These tools are new. They're not that great. They miss things. So now the whole DevOps movement is about, yeah, let's use a lot of automated tools that doesn't find everything well, and let's base all of application security on that. So I like DevOps, and I think you should do it, but it's not something you should depend upon for security. It's just one piece of the puzzle in how to build secure software, in my opinion. Here's some resources for you. I'll give you a copy of this presentation so you can look at my references. Here's the authorization cheat sheet. Here's NIST 800-162, right? I know it's an American standard. No one's perfect, right? But it's a good standard to read about access control if you're an identity expert. And also, here is the ASVS requirements about access control to help you as a tester or to help you as a developer build better access control layers in your software. All right. So why are we all here? We're here because we like security, right? And we're looking at the OWASP Top 10. We got number 1 done. Let's go take a look at cryptographic failures. And so if we look at this category has risen up. It shifts up a position to number 2. We used to call this category, what do we used to call this category? We used to call it sensitive data exposure. But that's just a broad symptom. It's not the root cause. When sensitive data is stolen or lost, very often the problem is some kind of broken cryptography. And so broken cryptography leads to loss of data, a loss of sensitive data. So let's look at this topic. Number 1, I recommend that you use HTTPS on all of your transport connections. There's no excuse to use HTTP. There's no excuse to do plain text communication, even in your backend networks. If any of you think in your brain that it's okay to have plain text communication anywhere on your network or on the internet, burn that out of your brain. It's a bad idea. We've wanted to use TLS on all connections for decades now. Not decades, but a long time. And we should make our HTTPS well configured with strict transport security, with cookie secure standards and other standards to make TLS on all of our websites well configured. Another part about applied crypto is understanding the key lifecycle. I have to generate a key, I establish it and store it and use it in my software. And of course, I have to do key rotation. A lot of systems I've looked at that do key management, they don't do key replacement very well. They do other steps well, but this step where you're doing, this step here where you're doing key rotation is the most difficult part of key management. It's the piece to focus on first, I think, right? The other part about modern applied cryptography is, where do you store your keys? Please don't store them in the database. Don't store your keys on a file system. Don't store your keys in your public GitHub repository. Don't store your keys on a file server somewhere, or put your keys in a secrets management vault or a key management system. And doing this in the cloud, proper key management, I think is even easier. Like I've seen some methodologies where I can get app level cryptography using Amazon's key management service done pretty quickly as a developer. So there's a lot of advances in this area. The other thing I don't like my keys to be extracted. If I can get away with it, I'm going to keep my key in the vault and never extract it and just use it in the vault itself. So as a developer, I can do crypto, I can encrypt, I can do digital signatures, but I can never get a copy of the key out of the secrets management vault even with my source code. That's the idea, key isolation. Now, let's say that doesn't scale very well for you. That's the problem with my advice here, is if you're sending every message into a key vault, that's not likely to scale, or it's likely to be too expensive. So what I do is I often store a master key in the database, and that master key is going to encrypt service level keys and data level keys that do the actual encryption, and that protect the keys we use in our individual applications. There's a lot of different strategies for managing your keys. It's one of the most important part about building a crypto system. Also, don't do crypto with your own code. I stopped doing that years ago. I use a library called Google Tink. Don't worry, even though Google kind of violates the world's privacy, you can still trust them for the crypto library. It's multi-language, it's cross-platform, it is open source where all eyes are on this library. It makes doing crypto harder to misuse. And it's interoperable between Java, Android, C++, Objective-C, Go, and Python. There are very few other languages that even compete with this. And again, it's open source as well. I highly recommend. Google Tink also has native integration into key management services. So it's something to consider for your own work. I read an article by one of the most internationally famous apps called Cash App in the US uses Google Tink as part of their work. Something to consider. There's also LibSodium from University of Chicago. That's really well-written C-level crypto library for your consideration. And so applied cryptography is extremely difficult. You want to bring in your most senior developers to build, procure, and verify your cryptographic implementations. And here I have a bunch of advice for you. I have the transport layer cheat sheet. There is SSL Labs by Qualys. That's a public TLS evaluation engine. For your private services, we got Team Germany. They have, we have OSAFT and Test SSL, right? The German engineers from the OWASP group there have written both these tools. They're free. You can get something free from our good German researcher friends. We also have the cheat sheet series, the cryptographic storage cheat sheet. All of these are decent resources to help you on your adventures of building cryptographic implementations on your own. All right. We're looking at the OWASP Top 10, and A3 is injection. What's an injection for the very first time is not in first place. It slid down to third place. We just had the knowledge that we need to stop SQL injection and to also stop cross-site scripting, or to stop command injection or LDAP injection or XPath injection or other kinds of injection. We have that knowledge as an application security community. We don't need to bring more awareness to SQL injection. So it's becoming lower on the list since everybody knows about this well. SQL injection happens when you insert untrusted data into a database query with string building. This leads to SQL injection. Let's look at one. Look at that code. Let's do a little code review, everybody. You ready? Can someone tell me where's the vulnerability? Where's that vulnerability? Let's go to red. It's right there. Easy to find, right? Boom. SQL injection. You're taking an open string variable and you're adding it to a query raw with string building. This little anti-pattern has led to SQL injection for like over 20 years. One of the biggest problems in web development, the third biggest problem today. How do you stop this problem? How do you fix this? If you're a firewall thinker, you may say, you should do some input validation to fix this, right? Well, that's the wrong answer. Input validation is not the right way to fix SQL. For example, this email address is legal and live. That's a SQL injection payload in my email address. It's valid via the HTML5 standard that defines a regular expression. There's the equal sign. There's exclamation point. There's an apostrophe. Everything I need for SQL injection is right there for me. And even valid data can cause injection. Input validation is not the most important defense. In this case, I have a valid email address that's live right now. And if I add that to a query here with string building, we see or one does not equal manico.com. That's or true. When you add or true to a database query, the entire table is released. The answer here is to always parameterize your queries. Here's an example of query parameterization. You remember this? This is very insecure. That same query done this way with no string building using query parameterization, that's how you solve the problem. Look, you can even do query parameterization in Python. Python is dead to me. I did Python once to build a cipher cracker for a crypto project I was doing. I got one space wrong, right? I got one little space wrong and it wouldn't compile. So Python is dead to me. I'll never use it, even though it's the most popular language in the world right now. Not me. I'm a Java guy. So anyways, I'm just kidding. We have parameterized queries. They work in Python. Be careful. Sometimes you can't parameterize a column name. Use exact match validation. And please parameterize all your queries. It's the first rule of secure coding. Here's Bobby Tables and the query parameterization cheat sheet to help your developers write some more secure code. We've also merged cross-site scripting into this category of injection. And I talk about cross-site scripting in other talks. It's a long discussion, but it's complicated to stop cross-site scripting. A combination of output encoding, URL validation, HTML sanitization, safe use of JavaScript, sandboxing, content security policy, trusted types, and cookie HTTP only flags, cookie prefixes for special cookie names, and it's just a very complicated topic, but we have the knowledge as an industry to defeat cross-site scripting if we choose to do so. What are we doing, everybody? Why are we here? We're here to look at the OWASP Top 10. We got that one. We got that one. We're going to look at insecure design next. If any of you are consultants in the application security industry, you know that we preach threat modeling as a big part of addressing design issues, right? So the recommendation is as your company, understand reference architectures. Like, how should I build a web app? How should I build a web service? How should I do mobile? How should services communicate on the back end, service to service? Have basic architectures that you want your developers to use, and then do threat modeling anytime you're doing a major architectural change, and try to conform developers to your reference architectures. I know many of you are already experts at threat modeling. The OWASP Top 10 addresses how important this is in A4 insecure design. I'm going to move on though. Again, I go look at like Adam Shostak, Avi Duglin. Take a look at Tony Uverquez in Atlanta. There's a lot of great thinkers about how to do threat modeling of applications. Go look at their presentations. They have good information in that area. We're now looking at A5, security misconfiguration. Now, why is this so important? This is a very important topic. 90% of apps have configuration problems, and we're rolling XEE, the XML external entity problem. We're rolling that into configuration, since many of the XML security problems are because of a poor configuration of an XML parser. So in this category, it can span anything from password length to file permissions to access control and more. You need to read the manual and have expertise on your individual frameworks. I like to read hardening guides and security guides for my frameworks so I know how to configure them properly. And be careful of the cloud. The cloud is not free. You have to administer and configure it properly like everything else we do in application security. Here's some hardening guides I've used in recent days, right? So I got this hardening guide for the Python Django work, or a Python Django project. We have WordPress. You know, no one should use WordPress is pretty bad security. I try to keep away from it. But if you're going to use it, please go through that hardening guide. We also have struts from Java, ASP.NET, Spring. Every major framework has some kind of hardening guide attached to it. Please read it and master how to secure that individual framework. Also, here's a neat little project from Mozilla. This is the Mozilla SSL configuration generator for TLS. It should be TLS, but we'll forgive them. You can pick which server you're using, which browsers you want to support, which libraries and configuration settings you want, and boom, there's your configuration file. I use this project to build my server. I got my A+ because I'm using a security configuration generator. And if you're still doing XML, please be sure to configure your XML parser. Here's a cheat sheet on many different ways that you need to configure your XML parser for all these different languages to avoid the billion laughs attack or XXE or other attacks against XML processors for web services and APIs. So security configuration is a huge category. It can involve anywhere from the operating system to the framework to the app server and more. If you can't verify the configuration, assume it's not secure. Read the manual. Be careful of your cloud configuration and make sure you achieve expertise in this area. Hey, what are we doing? We're looking at the OWASP Top 10. We did insecure design. We did security configuration. We're going to look at vulnerable and outdated components next. Now, what's the problem here, right? What's the problem with this category? The problem is that we see that, so it's number 2 in the community survey, insecure third-party libraries, but there's also enough data to make the top 10 via data analysis as well. So both the votes and the data both told us that vulnerable and outdated third-party components is very important in software today. Let's take a look at the world's most popular framework, WordPress. Back earlier this year, they were using an XML parsing issue with the media library that led to XML attacks again, XXE. This is a couple months ago. Here's Drupal, the second biggest framework in the world. They had a critical vulnerability with an insecure tar library right here. So why am I showing you this? Because these are 2 of the world's most popular ways to build a web application, and they both have had major critical vulnerabilities because they weren't keeping a third-party library up to date. That's terrible. And so the state of the art today is to scan your applications and look for insecure third-party libraries, right? We have like the OWASP dependency check. There's Maven versions for Java. There's NuGet Defense for .NET. There's PyPO for Python. And there's also there's retire.js for JavaScript. There's also Dependabot in GitHub. And that will just issue a PR to your project whenever that bot detects an insecure third-party library. So in some way, run tools to detect when a third-party library has a security problem. Also, please consider using less third-party libraries unless it's important to your business. Third-party libraries have a lot of baggage. They have security problems. It's opaque code you don't get to look into. They're harder to analyze. So I use third-party libraries when I have to. I use a good disciplined vetting process before I pick one. And then I use scanning tools to check them on a regular basis, like every day, to make sure my libraries are not out of date. We're looking at the OWASP Top 10 still, and now we're looking at A7, identification and authentication failures. Now, this used to be number 3, I believe, right? It used to be in the second position, and now it's 7. Why such a big change? Because in the last couple of years, we have better frameworks for authentication. We have identity providers like Ping and Okta and Auth0 and more that have helped us not have to build authentication code ourselves. We now use identity providers with the standard OpenID Connect. There's a way to do this easier today. That's the point. Now, the problem with this topic is it is extremely complicated. If you're going to build your own authentication layer, you have to deal with all of these issues and more. And there's many requirements to consider. Let's look at a few things. Again, I'm a U.S. person. I look at U.S. standards. You don't have to care about U.S. standards, right? I do. Oh, say, can you see? That's our national anthem, whatever. But even if you're not following NIST standards that the U.S. drives, as a security researcher, I still think you should read this. This is a very famous publication from the National Institute of Standards. What is it? It's the NIST Digital Media Guideline for U.S. companies. And it's extremely well written. And please, I read European standards. I read any standard on application security I can read because I gain wisdom, from other standards around the world. This is not an easy problem. So please read this. Now, what this says is, even if the risk of sensitive data being lost is low and there's no other risk to your application, if you look at this right here in the workflow, it says, do you have a low risk of sensitive information being leaked? And if the answer to that is a yes, then we should be using AAL2 level authentication, right? And what does that mean? AAL level 2, according to the same guideline from NIST, this is 2 different authentication factors. So what are they saying? They're saying, if you have sensitive data of any kind, then you need to be using multi-factor. And I agree with this. Europe is a little bit more ahead of the US when it comes to rolling out multi-factor, especially in the banking sector, and that's smart, right? Also, password policy in the US has changed quite a bit as well. And this, I see some Canadian companies and some North American companies support this as well. Again, you may not care about the National Institute of Standards. You may not care about NIST standards, but you should still read it if you're an identity expert to gain some wisdom on the work done here. And they're saying, don't limit the type of characters. It must be 8 characters or longer. And you have to force multi-factor anytime sensitive data is in play. Block context-specific passwords like a username or service. Block up to 150,000 common passwords. Make sure passwords are not in a public breach. Throttle brute force. Whoa. Throttle. Pardon me for a second. This is PowerPoint doing weird stuff. It's Microsoft. What do we got here? Here we go. We're back. So throttle brute force attempts. Drop the special character rules. No more security questions. I can look them up in social media and stop doing password expiration. This is a very new set of rules. And this password, for example, should be rejected. It's got the word password in it. That's a context word. It's also the 30,000th most popular password, and it's part of many public breaches. So I should not use that password at all. How do I store a password in my database? Let's ask the cryptographers here. If I'm building my own authentication system, how do I store a password? You should be using Argon 2 ID with these exact configuration settings. If anyone tells you to use bcrypt, don't listen to them. Bcrypt is a garbage piece of junk algorithm that nobody should use. And I don't understand why cryptographers love to recommend bcrypt, because bcrypt is crap. It truncates at 72 bytes. And how do you fix that? You get a pre-hash before you send the hash into bcrypt. Oh, then you get like all kinds of character problems. It is non-trivial. Don't use bcrypt. It's garbage. And you can tell anyone that I said it, because everybody else in the world loves bcrypt for no good reason. Use Argon 2 ID. If you have to, use scrypt. If you're doing a US system, use PBKDF2. And here's a cheat sheet that talks about, and yes, I wrote the cheat sheet with help from other people. I do support bcrypt because everyone makes me do it. But I really want to say bcrypt is crap. Don't use it for passwords. Use Argon 2 ID or use PBKDF2. Argon 2 ID is available everywhere. It's well supported, and it's a much better algorithm than the pure crap that is the 72-byte limit of bcrypt. You're welcome. You're welcome. It hurts me to say all that. A8, software and data integrity failures. Now, just a few things on this, right? This is a new category this year, and we rolled insecure deserialization into this category. The whole idea here is if you're doing a DevOps continuous integration, continuous deployment pipeline, CI/CD pipelines, right? If you're doing a pipeline, then you're downloading tons of scripts and running them on your server from a third party every day. This is crazy. So when you're running a script from a third party, always use the rule of two. Always check the integrity of that script twice before you run it. For example, if I'm going to run a code script to do code coverage testing, I'm going to check the hash of the script I just downloaded against the published hash of the website to make sure that matches. And then I'm going to take the script and compare it against the public repo of that software developer and make sure it hasn't changed. So that's just my general rule when it comes to data integrity and the scripts that we're forced to run. The rule of two, always check the integrity of a script that a provider wants you to run. Check it twice via automation before you run it. Category A9. Let's see where we're at. We're near the end of the OWASP Top 10, right? Where are we now? We've talked about all these, and we're almost done now. We got two more categories, logging and server-side request forgery. So why is logging on the list? Why is logging important from a security perspective? Why is that? Well, we see that security logging, it's number 3 in this community survey, moving up from number 10. And it's difficult to map this to data. How many hacks happened because logs were missing? But this category affects visibility, incident alerting, and forensics. It is a critical category that we do see in some of the data. So the goal of logging is to alert on security events. That's it. The rest is secondary. But the goal of logging is so when we're being attacked, we know about it right away. And please be careful. Is anybody even watching your logs? Even if you're doing the best logging, who's looking at your logs? We want to make sure that our security operations center teams, our network teams, they're actually intaking application logs. In order for them to do that effectively, your network teams and your developers need to agree on standard security events. That way your SOC can understand what is and what is not normal. One of the standards from OWASP I recommend, it's in a cheat sheet right now. I'm going to make this a standard next year. This is the logging vocabulary cheat sheet. This is a list of several hundred events that developers should log from a security perspective in their software. And this is a good starting point. So your operation team and your developers can talk and agree on what should be logged. This was donated to to OWASP from Nike Corporation. And I'm very impressed with this project, and I'm grateful that they donated it to the OWASP Foundation. I'm almost done now. So here's the application logging cheat sheet and the logging cheat sheet to learn more about OWASP's perspective on logging security for developers. Last but not least, server-side request forgery. Server-side request forgery has a low incident rate. We don't see this in the data as a top 10 issue, but it was the #1 item voted in the community survey. So it made the list because of the community vote. And as a professional myself, I agree with this. The reason why there's a low incident rate in the data is because scanning tools that we use in DevOps, they do not do a good job of finding this problem. I think that's one of the reasons why we don't see it as much. The world learned about server-side request forgery in August of 2019. This is when Capital One, a very large credit card bank in the US, had their Amazon Web Service domain hacked via server-side request forgery. Now look at this. This is a private internal URL at Amazon. It's the location of the web application firewall credential file. Just keep that in mind. And down here, we see curl to Capital One site. This was not example.one, it was capitalone.com. And there's a parameter, a URL, that's called an SSI, a server-side include. A server-side include is when the server loads a resource and embeds it on the web page in some way. And this was driven by this URL parameter. It was supposed to be some news article for Capital One, but an attacker who was an ex-Amazon employee changed that URL from some news article to the private intranet location of Capital One's Amazon Web Service credential file, and it worked. This web application firewall credential was embedded in Capital One's website after this attack. The attacker used those credentials to log into Amazon Web Service. There's no multi-factor setup for that. And then the attacker navigated to the S3 bucket and stole 100 million credit card applications, one of the largest breaches of banking data in history, one of. Equifax was a little bit bigger in terms of the number, the amount of data and the type of data. So this is server-side request forgery. Who's been vulnerable to this recently? GitLab had a problem with their webhooks that let me attack their entire infrastructure. And of course, we all know that Microsoft, there's the attack. There's Microsoft Exchange. This is still being exploited months later. Microsoft Exchange a few months ago had a server-side request forgery that lets me attack the infrastructure of your company through a parameter in Microsoft Exchange. Also, if you're going to build a URL that the server acts on, do it like this. Make sure if you're building a URL that your server acts on, that you do proper URL encoding if you're going to add a parameter to a URL that your server then acts on to load a resource. So, some final thoughts here. How do you stop SSRF? You want great authentication and great access control on your back-end APIs. And please avoid sending a URL, avoid sending a URL parameter that your server then acts on. And if you're going to add a parameter to a URL, use URL encoding. Also consider putting network controls around your web services to limit where they can load data from. I'm almost done. And that's the OWASP Top 10 2021 that we just talked about. Let's finish it. Yeah, we covered all 10 of those items. Thank you for listening to my talk. Just a few more notes. Please go read the Application Security Verification Standard. You can base your program of security for applications on that. Also, take a look at the cheat sheet series. It's a living encyclopedia of secure coding knowledge. And last, please test your applications for security. We have 2 free tools, OWASP Zap, OWASP Dependency Check, and many more. And here's the OWASP Web Security Testing Guide to learn more about testing applications for security. So what do we got here? Oh my hack, we are done. It's been a pleasure. If you have a question for me, I'm jim@manicode.com. I'm also at Manicode on Twitter and on TikTok. Please follow me in both those places. I produce videos on web security on a regular basis. I'm done. Thank you for having me. I'm happy to take questions before we